This is AP Calculus AB Worksheet 1-5 for the intermediate value theorem and the extreme value theorem. The acronym is IVT and EVT. All right, so we must first decide whether or not the theorems are guaranteed, and then the main thing is we have to decide if these are a must or a might be true based on this statement up above. So when I'm analyzing the statement, every single time I see the word continuous, I underline it. Anything that it says closed, these two symbols also mean closed, I underline. Those are the things that guarantee certain theorems. So for IVT, this is guaranteed because we have this word continuous here. So I saw the words continuous. And is extreme value theorem guaranteed? This one is also a yes. Why? Because there's two things. I saw the word continuous. And I also saw the word closed. So I could say, and closed. Another of the giveaways was these square brackets. So I could say, or you can also say that you saw the square brackets. All right, so we know that we can use each of these. That will help us in our quest to determine if these are true or false, or I guess might be true or must be true. So there's a lot of stuff that's going on here. Let's analyze it. There is a number C. This is some sort of X value, and it says, hey, we're in between A and B. C is somewhere in between A and B. We're in the correct range. And then this is the key part here. This has a translation. That translation, well, think about it this way. C is some point. F of C is some height. It says there's a height that is greater than or equal to all heights, because X is all X coordinates. F of X is all heights. So if I have a height that is greater than all heights or equal to the heights, then that is the definition of a maximum. So this is basically saying, hey, there is a value that is a maximum in that range. So it's just saying there is a maximum. Is there a maximum? Well, yes, EVT, extreme value theorem, guarantees that there is a maximum. It doesn't say where it is or when it is. It just says there is a case where there is a maximum. So this one must be true. Why? By the extreme value theorem. Reading this one, it's basically the same thing. All of this matches so far. The main difference is the inequality has changed signs. This is saying it's less than or equal to. This is the definition of a minimum. Is there a minimum? Well, yes, that must be true. Why? It's by the same theorem, extreme value theorem. Again, extreme in the word extreme value theorem comes from maximums and minimums. All right, there is a number C such that the height at that point is 0. Do we know that the height is 0? Well, if there is a way to guarantee that the height is 0, it will come from intermediate value theorem because this guarantees heights. It only guarantees heights in a rectangle if we know 2 points on here. This did not tell us what those 2 points are. Number 2, it tells you, hey, the x coordinate is 2, the y coordinate is -5, et cetera, et cetera. This one doesn't have any information, so it might be true, it might not be true. As a counter example, if I do a quick graph and just graph some sort of quadratic, some sort of parabola, notice that this graph right here does not have a height of 0. It does not have an x-intercept because it doesn't touch this x-axis. So this one might be true, it might not be true. So I'm going to say might be true. And we need more info to decide. So I have a feeling that that is going to be a very common answer, so I'm going to go ahead and copy that and get ready to go. All right, number 2. So again, I'm analyzing those key words. I see continuous, and ooh, this is kind of an interesting one. Open is the opposite of closed, so it's not closed. So looking at the theorems, which ones are guaranteed? IVT is guaranteed because, again, we saw the words continuous. Is extreme value theorem guaranteed? This one is actually no, because it was not closed. It's open. I saw the words open, which is the opposite of closed. So if there's anything that says there is a maximum value, anything that is talking about maximum or minimums, I can't even talk about extreme value theorem. This one is automatically no, where it's a might be true. That's what we can say, might. And in fact, I think I have a paste ready to go if I just paste that thing. That one might be true. We need more information. Maybe there is some sort of closed interval inside of here. Maybe there's a closed interval from 2 to 8 that we can talk about. But between 1 and 10, I can't do anything because that's an open interval. All right, let's talk about F. It has at least 2 zeros. Well, to analyze that, I need to take in the rest of this information that I haven't talked about. Let's go ahead and quickly graph what's going on. As a reminder, when I'm talking about this function notation, this 2 is an x coordinate and this -5 is a y coordinate. So this represents the point 2, -5 on the coordinate plane. Similarly, this is 5, 5, and this is 9, 5. I'm going to graph each of those 3 points. So let's make a quick little sketch of a graph. Sketch, and I'm going to go to 2, -5. So 2, -5, there's 2. I'm going to say there's -5. I'll even label them 2 and -5. I'm going to come over here to 5, which is right about here, I think. 5, and I'm going to come up to a height of what I say is 5. Again, I'm just kind of eyeballing it. And then I'm going to come down to 9, 5. I'm going to say 9 is right about there. 9, 5 is right there. And notice that each pair of points forms a rectangle for intermediate value theorem. So what I can say here is, let's go to like a dashed line with a different color. The first rectangle is this rectangle right here. This is the first intermediate value theorem rectangle. And then there's this second rectangle that comes down through 9, comes up here. Let's see, does that work? They should really be the same size, I think, but that's okay. Oh, no, they shouldn't be. This one should be slightly smaller than that one because this is a size of 4, that's a size of 3. Whatever, it doesn't really matter. It's not drawn to scale. I know that in this first rectangle, every single one of these heights has to be hit at least once. One of those heights is 0, and that's the definition of a 0. And an x-intercept is a 0. So I know it has to hit at least once there, and I know it has to be hit at least once there, so that's a total of 2 times. It has at least 2 times. That is actually true by the intermediate value theorem. So I can say this one is a must be true. Ooh, not in a dashed line, though. This one is a must be true. Why? It's by the intermediate value theorem. And I mean, there's a more complex way of what's going on, but this is enough for any sort of test. All right, now it's saying, hey, we're still between 2 and 5. Okay, actually not 9. So it's talking about this window right here, the first rectangle, and it says, hey, there's some point that I plug it in, I'll get out a height that is 3. Will I verify that there's a height of 3? Yes, because 3 is right about here, which is inside the rectangle. That height is guaranteed. If they had somehow said that's a 6, 6 would not be guaranteed because it's too high on the rectangle. 3 is inside the rectangle, so this one is a must be true. Must be true by, again, the intermediate value theorem, which guarantees heights. All right, moving on to the back. So tables are notorious on the AP Calculus AB exam. If you ever see a table, you have to play devil's advocate and poke holes in what you think is true. So the first thing that I'm gonna do is I'm gonna read. I see the word continuous, I see the word close, I even see these closed brackets. So that means that both of these are guaranteed. Why? That why is the important part, right? Intermediate value theorem is guaranteed because we saw the word continuous. And extreme value theorem was guaranteed because we saw 2 things. First, we saw continuous. Once you see that word, and you see some word that says closed, which we did see in this case. We could have also said we saw the square brackets. That's fine too, but this is enough to justify, yes, we can use extreme value theorem. Do you need to state this on the AP test? No, you'll never usually say that unless you are doing like an actual proof on a free response question. Most of these will be like a multiple choice question. If you do have to do a free response question, you'll say, because the function is continuous and closed, I can use EVT, and EVT says blank, blank, blank. Let's read on. Okay, so I have a table. I think I'm going to graph that or do a quick sketch of what's going on. So let's see, I have all positive stuff. So let's go ahead and make that right there. And I'm going to say here's 3, 4, 5, 6, and 7. Not to scale, so I'm going to do these 2 little bars that says I cut off a piece of my graph. We'll say 20 is right about there. Then it comes down to 17, which is right about there. We're going to say 12 is right about there. And it comes up to 16, which is a little bit less than 17, so a little bit lower. And then it goes up to 20 again, which is where I started. So, okay, those are kind of what the points look like. I have it graphed. Let's go ahead and read this question. So the minimum value is 12. I mean, it seems right. I mean, 12 was the lowest point. This point 12 is the smallest value in the table. So at first glance, the answer is must be true. This is actually a might be true. In fact, I have a copy paste ready to go. I should just do that, shouldn't I? Paste. It might be true. We need more information. The whole point of this is play devil's advocate. Go ahead and punch holes in their argument. Most people think, yes, the function is like that. Therefore, that is the minimum. Great. Here's what a function could be doing. It could be whoosh, 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 going crazy, right? And then the minimum's down there. You never know. We had incomplete data. In fact, we had very, very little information. Normally, we're given a function which has an infinite number of points. We used to have infinite points. Now we have 5. That is a huge decrease in the amount of information that we have. So you never know what's going on in between these 2 points. And that happens over and over in future units. Play devil's advocate. What is the worst case scenario? Maybe it goes crazy up like that and there's a maximum of 100. You don't know because we have incomplete data. I think I've kicked that dead horse long enough. Okay, so there exists a point in between 3 and 7, range is good, such that the height is 0. F of C is the height of some point is 0. Well, even on this graph, it looks unlikely that I'm ever going to touch that x-axis and have a height of 0. And indeed, this is might be true. Unlikely, in fact. I'll say might. Wait, I have a copy paste ready to go. My God, I'm so bad at the paste. No. I just want to, just paste for me, please. There we go. Paste it up here and then I'll drag it down there. That one's might be true because we need more information. Again, we could have had a graph that went like this and had multiple zeros. We don't know, right? And then part C is saying, hey, we have some number C, choose some x coordinate, and at that x coordinate, this thing happens. Again, you should be able to translate this word. This is saying some height is less than or equal to all heights. That is the definition of a minimum. So they're saying that there is a minimum. Well, there is a minimum. That is a must be true because extreme value theorem has been, we have the conditions for extreme value theorem. So this one is a must be true. And why? It's by the extreme value theorem. Extreme value theorem says there is a min, there is a max. Don't know when or where that happens, but there is one. And finally, our last question. Again, let's read. I see the word continuous. That's good. So I'll write down continuous. I saw that word, therefore, yes, that automatically proves we have intermediate value theorem. Ooh, I don't see any words that say closed. So maybe this one's a no? We'll check it out. These signs right here mean I have a closed interval because there's an equal to on the bottom of them. So this one is actually a yes as well because first we saw the word continuous, one of the 2 conditions. And the second condition is we saw these symbols, meaning it is a closed interval. Excellent. All right. And we also have some information here. Let's go ahead and graph that before we move on too far. What's going on here? So I have at -2, I come down here to a height of -5. So there's a point right there. And at +1, I guess I can, here, let's move these out a little bit. Let me retry this. I didn't realize they're going to be so close together. So here I'm going to put that at -2, definitely not drawn to scale. This is -2, and this is -5. There's a point here, and then there's going to be a point 1 that comes up here to +4. And I'm going to go ahead and draw myself a rectangle. Everything in that rectangle, every single height in that rectangle is hit at least once. Okay, it wasn't drawn the best here. Let me cheat and say, actually, that point I meant to move right there. Actually, this stuff I meant to draw right there. Perfect. Now it's good. Everything in that rectangle, all heights in that rectangle are guaranteed. All right, now let's ask these questions. Okay, there's some x-coordinate, and the x-coordinate is between -2 and 1. So we are inside of the rectangle in terms of the left and the right, such that the height of some point is 0. Well, do we have to have a height of 0? Yeah, well, this line is inside of this rectangle, so this one is a must be true. Must be true. Why? By intermediate value theorem. And again, the giant hint is every single time that I see f of something, that's probably talking about height. If I see f prime, that's a different story for a different lesson. All right, down here, it's saying kind of the same thing, but now it's saying, hey, the height is 3. And yet again, 3 is underneath 4. 3 is in that rectangle, so this one is also a must be true. So I'm going to go ahead and write down must be true. Why? Well, it's a height, so it's by intermediate value theorem. It's that rectangle. And then finally, we come down here. It says, hey, there is some x-coordinate, still in the correct range, where we have this thing happening. Again, some height is greater than or equal to all heights is a definition of a maximum. So saying, hey, there is a maximum. Well, because this is a yes, I know it's a little bit tricky because of those signs. This is a yes. This one is also a must be true. Must be true. Why? This is by the extreme value theorem. All right. That does conclude worksheet 1-5 for AP Calculus AB. There's the back. There's the front. Thanks for watching.